Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad geometry problem, and here we have a nice right triangle in which the length of its sides are n plus 1 whole square, n plus 2 whole square and 17 square root, and our target is to find the value of n. So that here we use the ninth Pythagorean theorem. So according to the Pythagorean theorem, we know that about Pythagorean theorem, hypotenuse square equals to base square plus perpendicular square. So this is called the Pythagorean theorem, and now we see that in the diagram we know that the side opposite to the right angle is known as its hypotenuse, and the side which join these two angles is known as the base, and the third side which is perpendicular to the base is known as the perpendicular. So that now we substitute these values in this Pythagorean theorem and we get its output in this form. So here we first write that base square, so that our base is n plus 1 whole square. So it will becomes n plus 1 whole square and its whole square, plus we have perpendicular square, so our perpendicular is written as n plus 2 whole square. So this is our perpendicular and it will become its whole square, and it is equals to hypotenuse square. So our hypotenuse is 17 square root and its whole square. So that in the next step we just solve this equation here and we find the values of n which is involved in this side length. So that in the next step we simplify this equation, and here we multiply these two exponents and we write it as n plus 1 to the power of 4, plus here we write n plus 2 and its whole power 4 equals to this 2 and square root are gone and we get 17. So now in the next step we solve here this nice quadratic equation. So that here we take a equals to n plus 1 and we take b equals to n plus 2. So when we substitute these two values in this equation, so we obtain a to the power of 4 plus b to the power of 4 equals to 17, and we call this as equation number 1. And now here you see that in the value of a and b, if we subtract a and b, then we obtain a minus b equals to n plus 1 minus n and minus 2. So that here we obtain a minus b equals to, these are gone, and 1 minus 2 equals to minus 1. So here you get a minus b equals to minus 1. So that in the next step we first call this as equation number 2 because we need this equation, and in the next step we move this minus b to the right hand side and we get the value of a equals to b minus 1, and we call this as equation number 3. So here we need all these three equations. So that first we focus on equation number 1, and now we further solve this problem to proceed equation number 1. So from 1 we have a to the power of 4 plus b to the power of 4 equals to 17, and here we add or subtract 2 times of a square and b square, and we obtain, we have a to the power of 4 and we write it as a square and its whole square minus 2 times of a square b square, plus we write b to the power of 4 as b square and its whole square, and plus 2 times of a square and b square equals to 17. Here we just write this a to the power of 4 as a square and its whole square, we write b to the power of 4 as b square and its whole square, and we subtract and add 2 times of a square and b square. So you get this equation. And now in the next step we combine this equation and you get a square minus b square and its whole square plus 2 times of a square b square equals to 17. And here we open this square identity and we write it as a minus b whole square into a plus b whole square plus 2 times of a square b square equals to 17. And here we use the value of a minus b, and you know that a minus b equals to 1. This is from equation number 2. So we put this value here and we obtain a minus b whole a minus b, the value of a minus b is minus 1. It will becomes a minus 1 square into, here we open this square again and we write it as a square plus 2 times of ab plus b square, and we have this 2 times of a square and b square equals to 17. And here you see that we have minus 1 square equals to plus 1. So this implies that it will becomes plus 1, and we write this expression as a square. Here you have 2ab and we write it as minus 2 times of ab and plus b square and plus 4 times of ab. So we write this 2 times of ab as minus 2ab and plus 4ab, and this is plus 2 times of a square b square equals to 17. And in the next step you focus on this term and you see that it will becomes the complete square of a minus b. So that we again write this equation as a minus b whole square plus 4 times of ab plus 2 times of a square b square equals to 17. So here we put the value of a minus b whole square. So we see from equation number 2, here we write equation number 2 implies that the value of a minus b is minus 1 square plus 4 times of ab and plus 2 times of a square b square, and we move the 17 in the left hand side and it will become minus 17, and this whole equation equals to 0. So it will becomes plus 1, and now we rearrange this equation and we write it as 2 times of ab and its whole square plus 4 times of ab, and this plus 1 and minus 17 equals to minus 16, and this whole equation equals to 0. So now you see that we have 2 be the common term, so we divide each expression by 2 and we get ab square plus 2 times of ab minus 8 equals to 0. And now we make the factors of this equation. So we have the factors of this equation are ab square, and we break our middle term and we write it as plus 4 times of ab minus 2 times of ab minus 8 equals to 0. So we take common ab from the first two terms and we obtain ab plus 4, and here we take common minus 2 and we obtain ab plus 4 equals to 0. And in the next step you see that we have ab plus 4 be the common term, so we take it common ab plus 4 and we get ab minus 2 equals to 0. So here we have two cases. The first case is we write ab plus 4 equals to 0, and the second case is we write ab minus 2 equals to 0. So in the first case we put the value of a here. So this is our equation number 3. Here we have a equals to b minus 1, so we put this value of a here. So our a will becomes b minus 1 into b plus 4 equals to 0. Similarly, this will becomes b minus 1 into b minus 2 equals to 0. So that now again we simplify these two equations and we move towards our final answer. So we multiply this b on both of the terms and we obtain b square minus b plus 4 equals to 0, and here you get b square minus b minus 2 equals to 0. So here you know that n b involve the or n involve the sides length of the triangle, so it cannot be a complex number. So here we need only real values. So we check this equation has real roots or not. So we check this equation by using the discriminant. So we have a equals to 1, b equals to minus 1, c equals to 4, and our delta written as b square minus 4 times of ac, and the value of b is minus 1 square. It will becomes plus 1 minus 4 times of 4 is 16, and it is equals to minus 15, and it is less than 0. So this discriminant tells us that if our delta less than 0, it means that it has no real root. So that if it this case gives us no real root, so we rejected this case and we will just proceed here this case only. And in this case we make the factors of this quadratic equation, and the factors are b square minus 2b plus b minus 2 equals to 0, and we take common b, we get b minus 2, and we take common plus 1 and we get b minus 2 equals to 0. So here we obtain two values of b. So the first value is b equals to 2, and the second value is b equals to minus 1. And now we put the value of b in equation number 3 and we get the value of a. So here we write it as from equation number 3. So our equation number 3 is written as a equals to b minus 1, a equals to b minus 1, and now we put the value of b, both values of b here, and when you put b equals to 2, then you get a equals to 1, and when you put b equals to minus 1, then you get a equals to minus 2. So in this question we need to find the value of n. So here we just use the values of a. So we have the values of a is a equals to minus 1 and a equals to 1. We have two values of a, and in the start of the problem we will take here our a equals to n plus 1. So we put the value of a here. So we know that a equals to n plus 1 and it is equals to minus 2, and in this case we have n plus 1 equals to 1. So now here you get the value of n equals to minus 3, and in this case we get the value of n equals to 0. So these are the two values of n in this question, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.